Welcome back to Spring into Math 8, guys. Today's lesson is actually going to be a review lesson of all the topics we've talked about in this chapter. So let's dive right into our content review. The first thing we talked about in this chapter, guys, was integer exponents, okay? So let's go ahead and review again what exponents actually are. Exponents, guys, our large number in the exponent is called the base, and the small number, which is raised slightly above the base, is called the exponent. In my example here, I have 5 raised to the third power, or I could say 5 cubed. And when I would break it down for you to see here, it actually stands for 5 times 5 times 5. And when I multiply those 5s together, I get a final answer of 125. Let's review the power of quotient rule. In yellow, I've highlighted the actual beginning problem. We have inside our parentheses x cubed over y squared, and outside our parentheses the entire problem is being raised to the 4th power. Let's use what we know about the distributive property, and we're going to distribute that power of 4 to what we have inside our exponents. So we can see here it's broken down for you in a very simple way. When we multiply the exponent of 4 times the exponent of 3 on the top of our numerator, we actually are going to get 12. So we have broken down there 4 groups of 3 of the x, which actually if we add them all together, we get 12 of them. And on the bottom, we've done the same thing for you. We are distributing that exponent of 4 to the power of 2, which is the y squared in the denominator. And 2 times 4 is 8. So I have 4 groups of 2 there at the bottom, and 4 times 2 is 8. So I can say that when we distribute that power of 4 to our original problem, our final answer is going to give us x to the 12th over y to the 8th. And you don't have to break it down any further from there because we don't know what x and y are actually worth in this equation. So just for reminding you, notice that what's on the outside of the parentheses is being multiplied by both the numerator and the denominator. A common mistake people make is they only multiply it by the denominator or the numerator and they forget about the other one. Don't make that mistake. Okay, let's apply the rule here. We have 4 raised to the third power over 5 raised to the second power, and the entire thing is being squared. So we're going to use that distributive property and multiply the power of 2 by the exponents that are inside our parentheses today. So 4 times 2 gives us 3 to the 8th, and 5 squared raised again to that second power is going to give us 5 to the 4th power. Now I've broken it down for you here so you can see what those actually stands for. I have 3 times 3 listed 8 times, and 5 times 4 listed, 5 to the 4th power listed as 5 times itself 4 times. Okay. When we multiply that out, we get some big numbers. On the top of our fraction bar, we get 6,561 over 625. Now, if I'm your teacher, I'm going to accept this as a final answer. However, on a test, they may ask you to simplify this even further. And I'm not going to show you the math, but however, I'm going to tell you what the actual simplified answer is. It's 6,561 over 625 comes out to approximately 10.5. Okay. Simplifying the expression here, we have a 4 raised to the 5th power over 4 squared. Now that fraction bar, that tells us to divide. And when we divide, we're doing repeated subtraction. So in this case, we're going to subtract just the exponents and leave the bases as they are. So let's subtract them. 5 minus 2 leaves us with 3. So 4 raised to that third power stands for 4 times 4 times 4. And when we work that out, guys, we're going to go ahead and get the final answer of 64. So 4 raised to that third power, or another way to say that, 4 cubed is equal to 64. Okay, that's it for topic 1. The second thing we learned in this chapter was about negative exponents. So let's go ahead and review that. First, let's start with the rule. We have x raised to the negative n power, which is equal to 1 over x raised to the negative n power. Basically, we want to get rid of that negative exponent, and when we do that, we move things into a fraction form, always over the number 1, and we move what the base and the exponent were to the denominator of our fraction, and we drop the negative sign. And by the way, x can never be 0 in this case. So apply the rule together. Inside our parentheses, we have x raised to the third power times y, and that whole thing's wrapped in parentheses and being taken to the negative 2 power. Now we're going to use that distributive property and we're going to multiply what's on the exponents on the outside by what's on the inside. So 3 times negative 2 is going to give us x to the negative 6, and y, which has no exponent on the inside of the parentheses, pretend it has a 1, and 1 times negative 2 is going to give you y to the negative 2 power. Now, we have to take it one step further here. Both those exponents are negative, and we want to get rid of the negative part. So in order to do that, we're going to make a fraction, and we're putting a 1 on top. And when we're going to drop x to the 6th times y, x to the negative 6 times y to the negative 2 to the denominator of our fraction. And when we make that simple move, we actually are allowed to drop our negative exponents. So our final answer is 1 over x raised to the 6th times y squared. Okay, you might also come across questions that ask you to write expressions with no fractions in them. Don't be frightened, pretty simple. Our example here is 3 over x times y. We want to bring that xy to the top of our fraction bar and get rid of the fraction bar completely. So when we're moving things from the bottom of our fraction to the top, we're actually going to need to add in our negative sign for our exponents again. So my final answer is 3 times x to the negative 1 times y to the negative 1. The x times y is being brought to the top of our fraction, and we have to add that negative part. Those two expressions are equivalent to each other. All right, last concept from the chapter, cube roots and square roots. A square root. Squaring a number means multiplying a number by itself. So let's square the number 3. So when we're going to square the number 3, we're going to multiply 3 by itself. So 3 times 3. And we give an example here of what that actually looks like when it's written in the proper form. 3 raised to the 2nd power. 3 is your base, 2 is your exponent. And you should know that there are two square roots for every positive number. And what I mean by that, guys, is the square root of 36 is actually 6 and negative 6. Let's look at that a little bit further. When we square 6, or take 6 to the 2nd power, we're actually going to do 6 times 6, which gives us 36. Now, we can't forget about the negative 6 we talked about, which is also an answer. So negative 6 squared, it means negative 6 times negative 6. And when you multiply two negatives, you drop the negative and you get a positive number. So negative 6 squared is also equal to 36. Now, a perfect square, which we've talked about previously, such as 121, has a square root answer of both positive 11 and negative 11. So perfect squares have both positive and negative answers. A square root is not perfect, will have a repeating or terminating decimal. Now, we've talked about terminating and repeating decimals before, back in chapter 1. All right, cube roots. Cubing a number means you multiply itself 2 more times. So to cube 3, we would multiply 3 times 3 times 3. Okay? Now, when we write that in a regular format, it would be 3 as a base, and also in this case, 3 as your exponent. So the symbol for cube roots is also listed here at the bottom. It looks like a funny division symbol with a line that jets out of it, and you have to, because it's a cube root, stands for 3, we have to stick that little 3 in there so we signify that it is for a cube root. Without that 3 there, we would just think it's a plain old square root. There is one cube root for every positive number. So the cube root of 8, okay? Now, we have to figure out what number, when multiplied by itself 2 more times, is going to get us back to the number 8. So 8 is a pretty small number, so let's start small. So I'm going to go with 2. 2 times 2 is 4, and we're multiplying it by 2 one more time to get us back to that 8. So we can say with confidence that the cube root of 8 is equal to 2. To undo a cube root, or to take the cube root of a number, when you have the problem of the cube root of 64, you need to think about what number, again, multiplied by itself 2 more times, is going to get us back to the number inside the cube root symbol, or the cube root box. In this case, it's 64. Okay, so 4 times 4 is equal to 16, and 16 times 4 is equal to 64. So we can say that the cube root of 64 is equal to that whole number integer 4. That's it for your content review, guys. See you in the next chapter.